All right. Anyway, we talked about what sinh and cosh were, right? And so just real quick, just sinh of x is defined to be e to the x minus e to the minus x all over 2. And cosh x was basically the same thing except the conjugate on top, e to the x plus e to the minus x all over 2. And then we also came up with some other definitions that tanh x, very similar to trig functions, was sinh over cosh, and sech was 1 over cosh, and cosech was 1 over sinh, and coch, cothx, I don't know if I wrote that one up yesterday, but the hyperbolic cotangent of x is 1 over the hyperbolic tangent, tanh x, which would actually be, instead of sinh over cosh, it's cosh x over sinh x. Okay, so we have kind of those basic definitions from yesterday, and I think that's it. And of course, we can use these formulas here to kind of come up with what this would be. Of course, this would be equivalent to e to the minus x plus e to the x all over e to the minus x plus, excuse me, I don't know why I switched those. E to the x plus e to the minus x, let's keep it like we normally do it, plus e to the x over, excuse me, minus e to the minus x. And of course, yesterday we also factored out an e to the minus x and got those cancel out. And so we would come up with something like e to the 2x plus 1 over e to the 2x minus 1 is what coach x is equivalent to. Okay, so anyway, let's just go back and get some nice results here. One thing that we have, we looked at some what they look like, but let's remember in trig we had sine squared x plus cosine squared x equals 1, right? Remember that? So the question might be, what do we have for hyperbolic things? So what we do have is that we have a couple of theorems here, I believe. So I've got a couple of spotters out here to correct me if I'm wrong, because they diligently worked through the chapter thinking it was due today. All right, but anyway, we got cosh squared x minus sinh squared x equals 1. Okay, so that's one theorem that we have. So instead of sine squared plus cosine squared is 1, we have cosh squared minus sinh squared is 1. And of course we could you know, prove that if you like. Let's look at another theorem. So I'll leave that one to you, but let's look at another theorem. We also have cosh x plus sinh x is gonna, if you add those up, that ends up being e to the x power. So if you add cosh plus sinh, you get e to the x. So we don't really have a nice mirror image theorem in the trig functions, right? If you add sine and cosine, you know, it's somewhere between -2 and +2, right? Kind of depending on where you're at. But anyway, so but let's just prove this one. Cosh x, remember, is e to the x plus e to the minus x, all divided by 2. So what I'm going to do is I'm just going to divide each part by 2 using rule of fractions, right? And then I'm going to add sinh x, which is e to the x minus e to the minus x all over 2. Once again, using rule of fractions, I'm just going to divide each part by 2. And then what do we notice here? We're going to have e to the minus x divided by 2 and minus e to the minus x over 2 cancel out, right? And so this is going to be equivalent to 2e to the x over 2, which is equivalent to just e to the x, right? So there we have a proof of that theorem. So that's kind of a nice result that we have as well. So this is part of why there's some neat stuff with hyperbolic functions. A lot of real life applications that you haven't seen yet as well. Part of why I like learning about this stuff, a lot more interesting than inverse trig functions, which basically you just learn to undo the other stuff. But anyway, at least that's how I remember it. Okay. Anyway, so let's look at a couple of other theorems. If I want to take the derivative with respect to x, I can't remember if I put these on the board. I still have it up there. Not really. I just did definitions, right? So we're going to take the derivative of these things. So the derivative of sinh, I mentioned them, but I didn't write them up. The derivative of sinh is cosh. Okay. We could actually prove that very quickly. Do you want me to prove that one? Or prove the other one? I can prove the next one. Well, let's do this. If I take the derivative with respect to x of sinh, it's the derivative with respect to x. I'm going to rewrite this. I'm going to pull that 1/2 out front, and I'm going to have e to the x minus e to the minus x. Is that another way I can rewrite sinh x? Instead of having divided by 2, multiply the quantity by 1/2, right? So if I do this, derivative of a constant times a function is the constant times the derivative of the function. Derivative of the difference is the difference of the derivatives. What's the derivative of e to the x with respect to x? Luke? What's the derivative of e to the x with respect to x? E to the x. Derivative of e to the x is e to the x, right? And then I got minus. What's the derivative of e to the minus x? Jordan? It'd be e to the minus x times the derivative of the exponent, right, which is -1, so that actually makes that a plus, right? I think you were saying it right. You just didn't say it like I did it. But anyway, so, right, because I've got that exponent, I got to take the derivative of the exponent as well because it's a function of x. Anyway, so, of course, what's this equivalent to? This is equivalent to cosh x, right? By definition, that's cosh x. So we prove that one. So this is a theorem that we have. What's really nice too is we have another theorem that the derivative of cosh with respect to x is sinh. So in the trig world, the derivative of sine is cosine, but the derivative of cosine is minus the sine. However, in the hyperbolic trig functions or hyperbolic function world, the derivative of cosh is sinh. Okay, so that makes it a little bit nicer that way. Okay, derivative with respect to x of tangent. Well, what's the derivative of tangent in the trig world? Secant squared, right? So the derivative of tangent nicely is sec squared x. So this is a real nicety. So a lot of parallels, a lot of mirror image type theorems that we have. I'm not going to prove all these so that we can get along and do those, but certainly you can prove any of these on your own as just using the definition and taking the derivatives there and making sure it's equivalent. Some of these may be proven for you in the book. The derivative of coach x, okay, is equal to minus cosec squared x. So if you remember, what's the derivative of cotangent is minus cosecant squared. So in this case, the minus shows up. So let's do need to pay attention when you do and don't have minuses that are mirror images to trig or when it's not there. So the derivative of cosine is minus the sine, but the derivative of cosh x is sinh x, positive sinh x. But in this case, the derivative of coach x is minus cosec squared. Okay, so once again, both of these are mirror images. Here's another one that we have. We have the derivative with respect to x. By the way, I use x a lot, which for exponential functions, x makes sense. When we were in trig, we would use theta for an angle, or t, which is what theta starts with, right? So we would use those variables a lot. But here, this is like e to powers, right? So it's we don't really use theta or t usually when you're, not that you can't, but when we're looking at hyperbolic functions, okay? Anyway, but the derivative of sech, and you will find, right, is, anyway, minus sech x tanh x. Once again, so the derivative of secant theta is secant theta tangent theta, right? Secant tangent. This one is close. However, what do we notice? We have a minus sign there. So this one is a little bit different. These two were very similar, right? So put a little check mark. Those were similar. So I guess maybe put a little star on the ones that were different. And then let's just look at real quick what the derivative of cosec x is. And once again, all these can be proven pretty easily using the definition of what these functions are. Cosec is 1 over sinh x. But anyway, this ends up being minus cosec x coach x. Okay, so once again, I've got that minus sign there, but if you notice, that is pretty much a mirror image. So 3 out of 4 of these are mirror images. The one that's different is the derivative of sech is minus sech x tanh x. So the derivative of cosec is minus cosec x coach x, if, assuming that I keep saying these right. Okay, and then let's go back and do some other results, I think. Assuming I don't want to do an example yet. Looks like my examples are primarily antiderivatives. I do want to make sure, because we got started a little bit late hooking up the equipment here. But let's look at some other theorems that we have. And one is the antiderivatives. Okay, so once again, to come up with a lot of these, if I have the antiderivative of sinh x with respect to x, once again, not really using t or theta because it's not typically an angle. But anyway, for these functions. But anyway, once again, the easiest way to come up with what this would be is if you know the derivative. The derivative of what is sinh? Cosh x. And then plus c. Always remember to plus c, according to Luke. So anyway, and then of course the integral or antiderivative of cosh x with respect to x is what? Sinh x plus c, because the derivative of sinh is cosh. So pretty basics there. And of course we can undo the ones that we know. For example, the antiderivative of sech squared x with respect to x. The derivative of what is sech? Tanh, right? And that one matched perfectly to trig. So anyway, that's tanh. And of course, we have the antiderivative of cosec squared x with respect to x. By the way, look at my 2's here. I just want to point something out. This is a 2 and this is a 2. How do I know that bottom one is a 2 and not a z? I don't have a line through it. If I wanted a z, I put a line through it, and I want you to do that too, because I really don't care if you loop it or not. That really depends on what font you're using, whether the 2 has a loop in it or not, right? So anyway, we talked about that in Calc 1, didn't we? So, all right, and then moving along here, what would this be? The derivative of what is cosec squared? Yeah, the derivative of coach x is minus cosec squared, so we put the minus on the right side then, right? and that would undo it and make it positive in there. So anyway, the antiderivative of cosec squared x is minus coach x. Similar, we have our two other ones, the antiderivative of sec x tan x. I'm not paying attention. If you see me write one incorrectly, like a trig function, let me know. But I'm trying to have the H on every time. But anyway, would be what? So in the trig world, the derivative of secant is secant tangent, but this is one that is different, right? So this will end up being minus sec x plus c. So this one, once again, that minus sign there, this one is different because it's different there. By the way, same thing here. This one is actually different. I don't need that z anymore. But this one up here is different because the derivative of cosh is sinh. The derivative of cosine is minus the sine. So technically that one's different as well, right? Anyway, and then of course I got one more here. If I got the antiderivative of cosec x coach x with respect to x, what's this equal? Minus cosec x plus c. So the easiest way to remember how to write it is write it like it's trig. Cosecant is CSC, and then add the hyperbolic. Not add it, but attach the hyperbolic h on there too. But anyway, so we have those. Those are just mirror images undoing of the other ones, right, that we had for derivatives. However, what don't we have? We don't have the antiderivative of tan x or sec x or cosec x, do we? These are squareds here or multiplied by something else, right, in here. So that's a product there. So let's come up with those, shall we? And once again, this is part of the flurry of new formulas and equations which we know to grow and love. These are the basic ones, and then you have the more involved ones on your front and back flat. So the derivative of what is tan? Well, nothing really that we know of, right? So what we have to do is we have to do some manipulation, and we have to do some thought process, but that's supposed to look like the natural log. Natural log, that's an ln. Natural log of the absolute value of cosh x, and then plus c. Okay, so that's what that one would be. Question might be, how would you prove that? Should we prove this one? How can you prove an antiderivative formula? Take the derivative of the right side. Take the derivative of the antiderivative. So the derivative of the natural log of the absolute value of cosh x plus c is going to be, of course, the derivative of the natural log of anything is 1 over that, right? So the derivative of the natural log of u, natural log of the absolute value of u is 1 over u. So it's 1 over cosh x times the derivative of what's inside by the chain rule, right? So what's the derivative of cosh? Sinh x, and of course sinh over cosh is equivalent to tan x. So boom, that's an easy proof, right? So you know, when you have the formula, it's easy to verify it, but your goal is to know the formula without having to look it up, especially on a quiz or test. We started out for some reason with tan. Let's do coach. The antiderivative of coach, also going to be a natural log formula, but it's going to be the natural log of sinh x plus c. So if you know one, it's going to be easy to know the other one. Okay, I'll let you prove this one. Very, very similar deal. Just it's going to be 1 over what we just did, right? So anyway, so that's a nice formula that we have there. So let's also come up with the antiderivative of sec x with respect to x. So this is not one we had either. This is going to be one that you're going to want to pay attention to, because this is going to actually end up being the inverse tangent of sinh x plus c. So this one is a little unique, to say the least. So you can't really say the derivative of what is sec, because we don't have that, but the derivative of the inverse tangent of sinh is c. Now remember, the inverse tangent, this is not hyperbolic. I am doing that. Anybody see that in your book? You got your book open? I just want to make sure that it's inverse tangent, not inverse hyperbolic tangent, which we don't even know what that is anyway. Huh? It's not in there? Okay. Perfect. Yeah, we got some work to do then. But that is, do you have this result? Can't find it? Well, we'll just have to assume I'm right. By the way, we could prove I'm right by taking the derivative of the right side. So I might come back to that. But anyway, so we got one more to come up with. Whoops. Let me go back to purple. Let's go to our happy color. Should have just marked that over in blue, because blue and red make purple. But anyway, don't believe me? Watch this. Oh yeah, we got purple. All right. Anyway, if I want the antiderivative of cosecant instead of secant, hyperbolic cosecant. So cosec x with respect to x, what's this going to be? So once again, theorem, proven fact, but this is going to equal the natural log of the absolute value of cosec x minus co x, hyperbolic cotangent, and then plus c, which hopefully is still on my screen. Okay, now, do you remember what let's just recall with, I'll use not red, let's use green. What was the antiderivative of cosecant x with respect to x? Remember? You need to look it up. If you don't know where to look it up, except for a test or quiz, then you're screwed. This might be in the front or back flap too. And they probably use U's. I'm guessing it's the natural log of the absolute cosecant x minus cotangent x, but we need to verify if it's the same sign. Do you see that anywhere? Absolute value of that? No minus sign in front, right? So what do you notice? This is this theorem here is a mirror image theorem, which is nice.